A positive. A positive blood type is common across Europe and West Asia and is closely linked to the spread of early agriculture. The A allele increased as Neolithic farming populations expanded from the Fertile Crescent into Europe and became dominant through population growth and long-term settlement. Dense sedentary communities changed disease exposure toward persistent close-contact infections. The A antigen remained common as these societies expanded and passed the trait through stable inheritance patterns. In Northern and Central Europe, A-positive frequencies reflect historical continuity of farming populations. Traits such as lighter skin and dietary adaptations developed alongside these groups but are governed by separate genetic systems. The Rh-positive factor later became widespread as populations mixed and expanded through standard reproductive inheritance. B-positive. B-positive blood type is most strongly associated with populations from the Indian subcontinent and Central Asia. This distribution follows ancient migration and mixing routes rather than climate alone. The B allele emerged later than A and spread along pastoral and nomadic corridors that connected Central Asia with South Asia. The B allele produces B antigens on no red blood cells. These antigens are linked to immune responses that perform well in environments with high microbial diversity and frequent exposure to animal-borne pathogens. Pastoral societies relied heavily on cattle, sheep, and goats, increasing contact with zoonotic diseases. The B antigen appears to have persisted because it supported immune balance under these conditions. The Indian subcontinent experienced repeated waves of migration from Central Asia over thousands of years. Each wave reinforced the presence of the B allele, making B-positive especially common in North and Central India and surrounding regions. Unlike isolated populations, this region remained a genetic crossroads, allowing B to spread widely. The Rh-positive factor again reflects population mixing and dominance rather than a single adaptive event. O-positive. O-positive has its deepest roots in sub-Saharan Africa. Before it became a hallmark of the Americas, the O allele served as a vital genetic shield for early human populations. In Africa, O-positive provided a significant survival advantage by offering natural resilience against severe malaria. This evolutionary head start allowed these founding populations to thrive and eventually populate the rest of the world. This ancient lineage is why O-positive is also the most common blood type among Native American populations and South American indigenous groups. This distribution is not coincidental. Genetic evidence shows that the first humans who migrated into the Americas from Siberia around 15,000 to 20,000 years ago carried this African-descended O blood type almost exclusively. That founding population effect locked O into dominance as these groups expanded across North, Central, and South America. The O allele does not produce A or B antigens. In isolated populations with limited outside gene flow, this trait remained stable across thousands of years. Because the Americas had minimal contact with Eurasian populations until very recently, there was little introduction of A or B alleles to alter that balance. Environmental pressure also reinforced this pattern. Just as the O allele offered protection in Africa, many pathogens in the Americas favored binding to A or B antigens. Individuals lacking those antigens had a survival advantage, especially in dense settlements and humid regions where waterborne disease was common. Today, O-positive in African, Native, and South American ancestry reflects a story of resilience, ancient migration, and long-term genetic continuity rather than simple lifestyle or diet. AB-positive. AB-positive blood type appears most often in East Asia, including Korea, Japan, and parts of China, where long histories of population interaction occurred. AB is the youngest blood type in the ABO system and forms only when A and B alleles are inherited together, making it more common in regions shaped by sustained genetic mixing. This blood type expresses both A and B antigens and produces no anti-A or anti-B antibodies, reflecting its combined genetic origin. East Asia functioned for centuries as a convergent zone between northern steppe populations carrying B alleles and southern agricultural populations carrying A alleles. Continuous migration, trade, and intermarriage allowed A-B to persist across generations. The Rh-positive factor spread later through population expansion and intermixing, making AB-positive the dominant AB subtype in these regions. O-negative. O-negative blood type shows its highest frequencies in parts of Western Europe, particularly among populations with long-term regional continuity, such as the Basque people and surrounding areas. The key distinguishing factor here is not the O allele itself, which is ancient and widespread, but the unusually high persistence of the Rh-negative trait. Rh-negative frequencies are highest in Western Europe and decrease sharply outside it. This pattern suggests a combination of founder effects, genetic drift, and historical population stability, rather than adaptive advantage. In large, rapidly expanding populations, Rh-positive tends to dominate, but in regions with limited inward migration, Rh-negative lineages persisted. There is no solid evidence linking O-negative specifically to indigenous Australian or other non-European populations at elevated rates. Those associations are often repeated online, but are not supported by population-level genetic data. O-negative does not confer special immunity or universal donor status in evolutionary terms. Its significance lies in European population history, isolation, and inheritance patterns, not survival superiority. A-negative. A negative blood type is most commonly associated with Northern European populations, particularly in Scandinavia, the British Isles, and Alpine regions. This blood type combines the A allele with the absence of the Rhd antigen, making it less common and more geographically concentrated than A-positive. The A allele spread with early agricultural societies in Europe, where settled living and grain-based diets became dominant. The Rh-negative trait, however, did not spread as widely because Rh-positive offers reproductive dominance in mixed populations. As a result, A-negative remained more frequent in regions with long-term population stability and relatively low outside gene flow. Mountain ranges, colder climates, and historically smaller population sizes helped preserve this combination. These conditions limited large-scale migration and mixing, allowing Rh-negative lineages to persist across generations. This is why A-negative appears more often in Northern and Central Europe than in regions with extensive historical migration. B-negative. B-negative blood type is rare worldwide and appears most often in populations with ancestry linked to Central Asian steppe, parts of Eastern Europe, and regions shaped by nomadic pastoral history. It combines the B allele with absence of the Rhd antigen, a pairing that requires specific inheritance and limited population dilution. The B allele spread through ancient steppe migrations as pastoral groups moved with livestock across Central Asia into South Asia, Eastern Europe, and the Middle East. The Rh-negative trait remained uncommon because Rh-positive dominance increases as populations expand and mix. As a result, B-negative persisted mainly in smaller or semi-isolated groups along these migration routes. AB-negative. AB-negative is the rarest of all 8 blood types. It appears most often in individuals with mixed ancestry from Northern Europe, East Asia, and parts of Central Europe, where long-term population blending occurred, but total population size remained relatively limited. This blood type requires 2 uncommon conditions at once: inheritance of both A and B alleles, and absence of the Rhd antigen. AB itself only forms when A and B lineages intermix over many generations. The Rh-negative trait further restricts its frequency because Rh-positive tends to dominate when populations expand and mix widely. As a result, AB-negative survives mainly in regions with historical admixture, followed by demographic stability rather than continuous large-scale migration. These conditions occurred in cultural crossroads such as trade corridors, border regions, and long-settled societies where different ancestral groups merged early and then remained relatively stable. Because A-B-negative produces both A and B antigens and no anti-A or anti-B antibodies, its immune profile reflects combination rather than specialization. Don't just watch the world, subscribe and understand it.